Now the next passage based problems is, first we'll go through the passage. Most materials have a refractive index which is more than 1. So when a light ray from air enters a naturally occurring material, then by Snell's law, sin theta 1 by sin theta 2 is equal to n2 by n1. It is understood that the refracted ray bends towards the normal, but it never emerges on the same side of the normal as the incident ray. Now this line is very important. This we have to understand what it means. That we will see in the next slide. According to the electromagnetism, the refractive index of the medium is given by relation n is equal to c by v, which is equal to plus minus under root of epsilon r mu r, where epsilon r and mu r are the relative permittivities of electrical permittivity and magnetic permittivity. Okay, and c is the speed of light. Okay, we know that c is the speed of light in vacuum and v is the speed in medium. Okay, now in normal materials both er and mu r are positive, implying positive n for the medium. When both er and mu r are negative, one must choose the negative root of n. Okay, now this is given in the passage. We have to choose negative value of mu or refractive index. Such negative refractive index materials can now be artificially prepared and are called metamaterials. So metamaterials have their epsilon r and mu r values less than 0. They are negative. So in that case their refractive index would be also 0 or negative. They exhibit significantly different optical behavior without violating any physical laws. Since n is negative, it results in a change in the direction of propagation of the refracted light. However, similar to normal materials, the frequency of light remains unchanged upon refraction even in metamaterials. So in these metamaterials, the optical properties or optical phenomena, they are not going to change. What is going to change is that refractive index is negative. Now we have to physically understand the meaning of negative refractive index. Okay, and also we have to understand what this line means. It means that in normal materials, okay, that means let us say this is air and you have this medium which is made out of a normal material. This is the normal and this is the incident ray. Okay, so this incident ray is making an angle I, and if the refractive index of medium is more than 1, then this would bend towards the normal. Okay, this is the general phenomena that we observe. Now it is written here that it never emerges on the same side of the normal. That means if this is the normal, the ray after getting incident, it emerges into the new medium, but not on this side. This never happens in case of normal material. Okay, now this is the total passage. Now based on this we will attempt the problems. Choose the correct statement. The speed of light in metamaterials is v equal to c n. No, that cannot be true, because even if n is negative, the speed of light will be given by v by c by n. Now if n is negative, we have to take its mod. If n is positive, the mod will be same as that of the value of n. So the velocity will definitely reduce because no change in the optical properties. It's already given. So option B is the correct one. Now let us look at the next problem. For light incident from air on metamaterials, the appropriate ray diagram is. Now it is given to us that n is negative for metamaterials. So when n is negative, the value of n is also given by sine theta 1 by sine theta 2. Now sine theta 1 is angle of incidence, which is always positive, so sine theta 1 is always positive, which implies that sine theta 2 is negative, and sine theta 2 is negative means theta 2 is negative. Now the sense in which theta 2 is measured is in this direction. If theta 2 is negative, that means it is in this direction. So the ray incident with theta 1 in one medium gets refracted on the same side of the normal, because theta 2 has to be negative. So among the four options, option C is the correct one. Let's look at the three-dimensional image of it. Incident ray is incident on the interface. This theta 1 is the angle that it makes with the normal, okay, and theta 2 is the angle that the refracted ray makes. Now the important thing is that the incident ray and the refracted ray, they are on the same side of the normal, n in dash, okay.